This next problem offers our first negative a value here. That changes the end behavior, but it doesn't change any of the roots the way we see them here. So the first root, at least that we would normally maybe regularly identify, is a negative 2. So x equals negative 2 and x equals 5 by the same standard that we've also already done. That guy there, hello, that guy there can be also written as x minus 0 quantity squared. So not only is it a double root, it also has a root at 0. So x equals 0 is another root, but we want to make sure that we acknowledge it as a double root. Okay, so when we identify them here, 1, 2, 3, 4, 5, there's my dot for 5. 1, 2, there's my dot for negative 2, and there's my dot for 0, but I'm going to put the asterisk there just to remind myself. The fact that it's negative means the end behavior now is going downward. Okay, this direction, and the fact that this is a regular root to the first power, we're going to cut straight through. And as we come back down towards this double root, we're going to bounce off of it, and then change direction yet again to come back to the quick one. So it's a quick turnaround because they're closer. The further away, the more distance you're going to be able to go away from the x-axis. But that's that. While we're at it, let's just do another quick one here. This one here offers our first triple root. Okay, the three roots are identified as x equals 2, x equals 3, and x equals negative 1. Labeling those accordingly, 1, 2, 3, and then negative 1. The x value roots here at 2 and 3 are normal. I forgot to star that guy, and also over here we can make that an asterisk where there's something special. I don't identify these any differently than the double root. It's just something to make sure that we pay attention to when we get there, and remind ourselves it's different. It's a positive a value, so ultimately we go up. As we come back down, it's going to curl but quickly because they're close together. And then as we come back down, we need to recognize that this is going to cross. It's identified on the worksheet here as through slowly. I kind of call it a squiggle because it does a little squiggle type of thing there. And essentially, if you look at graph of y equals x cubed, it looks like that. We kind of are familiar, should be somewhat familiar with y equals x cubed. That basically, that little squiggle there is the same squiggle we see here. And if you just kind of show that it's cutting sideways slightly across the x-axis instead of straight through like we've seen it already do in a number of different places, you're acknowledging that it's a triple root. Something different is happening there. It doesn't have to be perfect, but as you see, there's something different going on, and that's what we're going to be looking for when we're checking right or wrong.